them was a cold, lonely sentinel named Pluto, discovered in 1930 by the tireless observations of Clyde Tombaugh. This mysterious world at the ragged edge of our system was a source of endless fascination for 3 generations. It was the absolute limit, the final frontier, a jagged little world of rock and ice that was, nevertheless, family. But in 2006, the consensus shattered. Pluto was not a final endpoint. It was merely the beginning of a larger, more complex story. That year, the International Astronomical Union convened, and with a single decision, they demoted Pluto, stripping it of its planetary status and creating a new classification, the dwarf planet. The reclassification was not arbitrary. It was forced by discovery. By the late 20th century, more powerful telescopes were revealing a vast, cluttered landscape beyond Neptune known as the Kuiper Belt, a region teeming with icy bodies. In 2005, the discovery of Eris, an object more massive than Pluto, made a choice inevitable. Astronomers had to either declare dozens of new planets or finally create a rigorous scientific definition of the word. The standard they adopted required 3 conditions. A planet must orbit the sun, it must be massive enough to be spherical, and critically, it must be the gravitational dominant, having cleared its orbital neighborhood of other comparable bodies. Pluto, sharing its realm with countless fellow Kuiper Belt objects, failed the 3rd test. The decision caused a seismic shock and public outrage, particularly in the United States, as it was the only planet discovered by an American. Yet, while the world was debating a label, a quiet revolution in our knowledge of this distant world was already underway, preparing to prove that Pluto was anything but insignificant. The heart of the detective story. For decades, Pluto was little more than a ghostly, blurry pixel in our most powerful telescopes, a mysterious point of light about which we knew almost nothing. It was assumed to be an inert, geologically dead world, a frozen ball of primordial ice scarred by billions of years of silent impact craters. But the truth could only be found by looking closer. In a profound cosmic coincidence, the same year that Pluto was stripped of its planetary status, NASA launched the New Horizons mission. This was our first and only cosmic detective, sent on a daring 10-year, 5 billion kilometer journey through the dark expanse to finally confront the ninth world. On July 14th, 2015, the probe successfully executed its flyby, passing just 12,500 kilometers from Pluto's surface. Scientists held their breath as the first high-resolution images began to stream back to Earth. And what they saw didn't just challenge their assumptions, it revolutionized them. The single most breathtaking revelation was a massive, brilliant, heart-shaped region named Sputnik Planitia. Far from being a cratered wasteland, this heart was a colossal glacier of frozen nitrogen, methane, and carbon monoxide, stretching over 1,000 kilometers. But it was what the glacier lacked that was truly stunning: craters. In the solar system, impact craters are the universal fingerprint of age. A lack of craters means a surface is geologically young and active. This means Sputnik Planitia is alive right now, constantly resurfacing itself. Scientists discovered that the nitrogen ices in Pluto's heart act like a fluid in a lava lamp. Warmer ice from the depths slowly rises, renews the surface, and then cools and sinks back down. This is an elegant, active geology that nobody expected to find on such a small, cold world on the system's back end. This dynamic heart proved that Pluto was not a relic of the past, but a living, changing entity. The ocean and the comet theory. The dynamic geology of Sputnik Planitia demanded an explanation. Where was this tiny, cold world getting the internal energy to remain active? The answer proved to be even more profound. Cryovolcanism and the probable existence of a subsurface ocean. New Horizons images revealed colossal structures that look precisely like Earth's shield volcanoes, but with one critical difference. One peak, Right Mons, is 150 kilometers in diameter and 4 kilometers high. These are cryovolcanoes, ice volcanoes that erupt not with molten rock, but with a semi-liquid slush of water, ammonia, and methane. The existence of these massive, geologically young features means that Pluto's interior has retained its heat far longer than anyone believed possible. This led scientists to a staggering hypothesis. This internal warmth is likely generated by the radioactive decay in Pluto's rocky core, and models show it might be enough to maintain, beneath a thick ice crust, a deep ocean of liquid water. Such an ocean explains the surface geology perfectly. If this ocean had fully frozen, the expanding ice would have crushed Pluto, leaving visible contraction cracks that we do not see. This discovery places Pluto alongside worlds like Europa and Enceladus, the system's prime candidates for the search for extraterrestrial life. And then there is the theory that Pluto itself is a giant comet. Analyzing the specific chemical mix of Sputnik Planitia's nitrogen ice reveals striking similarities to the composition of comet 67P/Churyumov-Gerasimenko. This led to the creation of the giant comet model, suggesting Pluto didn't form conventionally, but was assembled from the collision of perhaps 1 billion comets. It is a world with an atmosphere 100,000 times thinner than Earth's, composed of a blue-hued haze of complex organic molecules that freeze and evaporate in extreme seasons. Pluto is not a dead, forgotten rock. It is a profound lesson in mortality and complexity, proving that even in the heart of total darkness, there is a story of life and renewal waiting to be told. The horizon is not the end. It is only the beginning.